Hi, Assalamualaikum warahmatullahi wabarakatuh. In the previous video, I have explained how you can use the idea of Cramer's rule in order to solve the system of linear equations here, where you have two unknown variables x1 and x2. Therefore, in this video, I'm going to continue with the implementation of Cramer's rule in order to solve this linear system here, where you can see that we have three different unknown variables to solve. Okay, right. Here are the linear equations. We have three linear equations here, and these equations can be written in terms of matrices equations that are going to look like this. Here we have matrix A, which contains the coefficients of the unknown variables. So for example, for the first line here, the coefficients here is going to be -1 to -3. And for the second line here, the coefficients here is 2 for x, 0 for y. There's no y here, so here is 0, and z is 1. And for the third line here, we have 3 for x, -4, and 4. So here is matrix A, and this is a column matrix for the unknown variables. And right next to it will contain the constants on the right hand side of the equation. So here we have 1, 0, and 2. So here is B. Now our first step is of course to focus on this matrix A and find its determinant. Okay, so that is what we're going to do first. Determinant of matrix A. Okay, so here we have matrix A is -1 to -3, 2, 0, 1, 3, -4, and 4. And if you consider the second row expansion, so that is what I'm going to do. I'm going to consider the second row expansion. Okay, therefore the determinant of A can be found if you consider this position here. So we have A to 1 with cofactor C to 1, and then A to 2 with cofactor C to 2, and this one here is A to 3 with C to 3. Well, A to 1, the value of A to 1 is 2, so you need to find the cofactor of it. Next is, this one is A to 2, this is 0, so here we've got 0. And A to 3 is 1, so 1 times C to 3. So that is what it can be simplified to. Now our job is to find what is the cofactors related to determinant of A. So I'm just going to use this space. Well, in order to find C21, we're going to focus on M21 first. M21 can be obtained when you delete the second row and the first column. So the remaining values that you got is 2, -3, -4, and 4. Based on this, you can find the determinant of this matrix. So 2 times 4 is 8, minus these two values multiplied together. So here we have 12, and so M21 is -4. Therefore, C21 is going to be, well, the formula is actually C21 here is -1, 2 and 1. 2 plus 1 is 3, so here we have 3 at the top. And then you take the value of M21, put it right next to it. And we know that this is going to be giving us a negative sign. So -1 with -4, you will get the value of C21 is 4. and you can plug in the value obtained here right next to it. So here is 2 times 4 plus, okay. Now our job is to find what is the value of cofactor C23. Well, I think I'm just going to use the space, so let me just erase this. Right, now what is C23? Before you can find what is cofactor 23, you need to find the minor associated to it, which is M23, and this can be obtained by considering the values of the remaining of matrix A when you delete the second row and the third column. So the values remained are -1, 2, 3, -4. Based on this, you can find determinant of this 2 by 2 matrix. Here we have 4 minus 6, which is -2. Therefore, C23 is just -1, 2 plus 3 is 5, and then plug in this result right next to it. And we know that this one here is going to be -1 because the value here is odd value, so -1, so -2 will be +2, okay. And we are going to plug in the result here right next to it. So here we have 1 times 2 is just 2, therefore determinant of matrix A is equal to 10. That's the value of determinant of A. Now if you want to find the value of x, so let's say you want to find this value of x, what you need to do is you need to create a new matrix. This new matrix, we're going to call it A1b, okay, because 1 here is also referring to the position of x being the first unknown variable. And in order to create this new matrix, you will substitute matrix B into the first column of the original matrix A. So therefore, the new matrix A1b is going to look like this. So on the first column here will be the value of B, which is 102, okay. And then and then we will just take all the remaining values of A. So 2, 0, -4, and it is -3, 1, and 4. Right, our next job is to find the determinant of this new matrix, and you can see that the easiest way is by considering the second row expansion, okay. Therefore, the determinant of this matrix can be considered when you take this value here. So this is A22 with C22. Okay, so the formula is like this. Next, A23 with C23 plus is, I'm sorry, let me just do it once again. So here it's going to be this is A21, yeah, second row first column, so A21 C21 plus this guy here is A22 C22 plus this one here is A23 C23, and we can easily see that this is 0 and this is 0 for this part. Therefore, the formula to find the determinant of this matrix is just going to be 1, A23 is 1 times with C23, so this is going to be C23. Okay, how do we find the value of C23? Okay, I'm just going to use this part. Well, to get C23, you need to consider what's the minor for 23. which can be obtained when you delete the second row and third column. Therefore, here we have remaining values of 1 and 2 to -4. Based on this, you can find its determinant. So here you multiply the two values together is -4 minus this one is negative, subtract with 4. So here we have -8. Well, C23, we can see clearly that 2 plus 3 is 5. 5 is odd number. Therefore, you're going to have a negative sign right to it. And then just plug in the value of -8. And the answer is going to be positive. So that is C23. 8. The value is 8. Just plug in right here. So that is the determinant of this new matrix. Now, using the formula, using the idea of Cramer's rule, therefore, x is just going to be 8, this result, divided with 10, which is the determinant of A. So Cramer's rule say that in order to find x, you can take the determinant of the new matrix here, A1b, and then you divide that with the determinant of matrix A. Therefore, you have 8 divided with 10, and the answer is 4 over 5. So that's the value of x. Okay, so we are done with finding the value of x. Next, we are going to move on to find the value of y. Okay, so we're going to focus on finding the value of y. So we need a new matrix for that purpose, and we are going to call this matrix here is let me just erase this. So we need a new matrix for that. So here y is the second unknown variable. So we need a new matrix associated with y. So here we call it A2b. And what is A2b? That means you are going to substitute matrix B here, the column matrix B, into the second position, the second column of matrix A, because the second column here is associated with the second unknown variable, which is y. Okay, so substitute B into the second column of A and retain other values of matrix A. Well, the new matrix here is going to look like this. For the first one here, we have -1, 2, 3, and the second column is going to be matrix B, 1, 0, 2, and the third column is the original matrix A. Okay, so here we have the new matrix, and what we need to find is we need to find the determinant of this matrix. And again, I think the idea is we can use the second row expansion. It looks easier to do that. So using the second row expansion, determinant of this new matrix can be obtained when you consider 2 with C to 1. So here is at the position of second row and first column, so C to 1, plus 0 with C to 2, which is going to be 0, and then plus 1 times with C to 3. Okay, so here is the position of the second row and third column. So you need to find C to 3. Right. So what we can do next is I can start off with finding what is C to 1. So in order to find C to 1, I need this minor to 1, which can be obtained by deleting the second row and first column. So here I have 1, -3, 2, and 4. So these are the remaining values after you have crossing out the second row and first column of this matrix. And that can be the determinant of this matrix, the determinant of this matrix can be easily found by multiplying these two together. So we have 4 minus, the result here is negative 6, therefore m21 is equal to 10. Next, C21, well, you can see that 2 plus 1 is 3, 3 is an odd number, therefore you're going to have a negative sign, and here just plug in the value of m21 right next to it, and therefore the value of C21 is just negative 10. Plug in this value into the position here, so 2 times negative 10. Okay. Next is I need to find what is C23, and that can be obtained by first considering M23. So what is M23? Well, you need to delete the second row and the third column. So the values that you will consider are negative 1, 1, 3, and 2. Based on this, the determinant is negative 2 minus 3, which is negative 5. Therefore, C23 is going to be, well, 2 plus 3 is 5. 5 is odd number. Therefore, here we're going to have a negative 1 sign. So your negative sign. And this result here, just plug in right next to it. So negative, negative is positive. So C23 is going to be positive 5. Plug in the value right at this position. 1 times 5 is just 5. Therefore, negative 20 plus 5 is negative 15. So this is the determinant of this matrix. Now you can find the value of y as, take this value, negative 15, divided with a determinant of the original matrix A. So negative 15 divided by 10. You can simplify that and it will be negative 3 over 2. Okay, so that is the value of y. Okay, there you go. Now, next we are going to continue our journey and we're going to focus on finding the value of z. So here is the third unknown variable, and therefore we need a new matrix associated with that. And this new matrix will be obtained when you substitute B, okay, and you put it right here on the third column of matrix A. So that is the new matrix that we need to create that has something to do with finding the value of the third unknown variable z. Okay. So let's write down our new matrix A3B. This is obtained by, first we're going to write down all the values of matrix A from the first column up to the second column. Okay, so that's what I'm going to do next. So negative 1, 2, 3, 2, 0, negative 4. And then the third column here will be replaced with matrix B, which is 1, 0, 2. Again, what you need to do next is you need to find the determinant of this matrix, and I'm sure you can see that it will be easier to do that by considering the second row expansion. Okay, so using the second row expansion, determinant of A3B can be obtained when you consider this guy here. So that is A21. So 2 times with C21 plus this guy times with its cofactor. But since this is 0, well, here we got 0. Plus, again, this is also 0. So if you multiply with its cofactor, it is going to be 0 as well. So the process is so much simplified. Okay. Based on this, I know that I just need to find the value of cofactor to 1, and we will start off with finding what is m to 1. M to 1 can be obtained when you delete the second row and the first column. Therefore, the remaining values that you have to consider are 2, 1, -4, and 2. So this part. And based on that, its determinant is 4 minus -4, and this is equal to 8. Well, C21 is going to be 2 plus 1 is 3. 3 is an odd number, therefore we're going to have a -1, so negative sign right to it. And then M21 is 8, so just plug in the value right there. C21 is -8. Consider this value to be put right next to it here. So 2 times -8 is -16. So that is the determinant of this new matrix. Therefore, the value of the third unknown variable, which is z, is -16 divided with 10, determinant of a. This one is going to be -8 over 5. So that can be simplified as such. Okay, well, I think I have I've come to the end of this video, and in this video what we have done is basically demonstrating how you can use this idea, the Cramer's rule, in order to find the solutions to the unknown variables. Okay, thank you very much for watching, and I'll see you in the next video.